This is the Atwood Machine example problem from the notes. So in this particular situation, we have a pulley right here. A string is going over the pulley, and on one side we have a 4 kilogram mass, and on the other side we have a 3 kilogram mass. First step, as always in solving any of these problems, is to draw the picture. I did this on a separate sheet to give us a little bit more room. So here's my pulley. Here's my string going down to my 3 kilogram mass, and my string going down to my 4 kilogram mass. I drew the forces on each one of these blocks. The 4 kilogram mass has tension going upward. Force of gravity, I call the force of gravity 1, going downward. Here's the 3 kilogram mass, tension again upward, force of gravity 2, downward. In this particular problem, I'm going to give each block a number. So I'm going to call the block on the left block 1, and the block on the right block 2. If there's a key to this problem, is to make sure you realize at step 2, when we assign our positives and negatives, that it's not up positive and down negative. We have to worry about how the system's going to go. The system can go clockwise, or the system can go counterclockwise. So it's very important that we know which way the system might move so that we can assign positive and negative directions accordingly. So step 1, we drew our picture and all of our forces. Step 2 was our positive and negative direction. Step 3, if we had anything to break into components, we would do that, but no forces are at angles. So now we can move to step 4, which is adding up our forces on our different blocks. So we have to do now, we have 2 blocks, and we have to do block 1 and block 2, and we're going to do those separately. So this little 1 here denotes that I'm doing the equation for block 1. So I look at my forces on block 1. T is going up and in the clockwise direction. So that's going to be a positive force for block 1. And force of gravity 1 pulls downward, which would make my system go counterclockwise. So that is a negative force. So minus force of gravity 1. Since I'm out of forces, that's going to equal the mass of block 1 times the acceleration of the system. Now for block 2, I look at my forces, and notice going clockwise, force of gravity 2 is the force that's positive here. And then that makes tension the negative force. So that's minus. And that's going to equal the mass of the second block, m2 times a. What we have is a simultaneous equation because we do not know acceleration, which is what we are trying to find in this particular problem. And we do not know the tension. So 2 equations, 2 variables. What happens here is the easiest thing we can do is add these 2 equations. When we do that, I would get tension minus force of gravity 1. Those are the forces acting on the first block. And I'm going to add to it the forces acting on the second block. So that's plus force of gravity 2 minus tension. And that's going to equal these added up, the m1a and m2a. So I get m1a plus m2 times a. From here, if you take a look at our forces section, I have a positive t minus t. That's going to cancel out. That will always happen on an Atwood machine problem. Your tensions will always cancel if you do this right. I'm going to rearrange my forces of gravity so that I don't have a minus sign floating in the front. Otherwise, that tends to get lost. So I have force of gravity 2 minus force of gravity 1. And that's going to equal m1a plus m2a. Now we're trying to solve for a. We have it in 2 spots on the right side of our equation. So in order to get just 1a, we're going to factor it out. So my left side remains unchanged, force of gravity 2 minus force of gravity 1. And when I factor out my a, I get a multiplied by the sum of m1 and m2. To finish up solving for a, I'm going to divide my m1 and m2 to the other side. leaving me with force of gravity 2 minus force of gravity 1, all divided by m1 plus m2. Plugging in my numbers, force of gravity 2 is mass of block 2, which is 3 kilograms, times 9.8 meters per second squared, minus force of gravity 1, which is the mass of block 1, which from the picture is 4 kilograms, times 9.8 meters per second squared, all divided by mass 1, which is 4 kilograms, plus mass 2, which is 3 kilograms. And all of that is going to give us acceleration. So when we plug that into our calculator, we should get that the acceleration is negative 1.4 meters per second squared. We take a look at the sign. It says negative. Does that make sense? Well, the heavy one is on the left side, meaning that if this one is going to be the one that would fall. So it's going to accelerate with 4 going downward, 3 going up. That's counterclockwise. We said that's negative. So that means that our sign is correct. So we probably did this right. And that's how we do the Atwood machine problem, solve for acceleration.